This is apparatus and tool that we use in this experiment. Now let's go to procedures.
Part 1 to analyze the accuracy of the sensors. First, prepare standard temperature reference points. Use an ice bath 0 degrees Celsius and boiling water 100 degrees Celsius as non-reference temperatures. Ambient air 22 degrees Celsius using a control water bath or heater. Second step is connect each sensor, thermocouple, RTD, thermistor to the data acquisition system or digital multimeter.
Place the sensor in the reference temperature medium. Then, record the sensor output, voltage for thermocouples, resistance for RTDs and thermistor, and convert to temperature using the appropriate formula or conversion table.
Repeat the measurements for all reference point, which is 0 degrees Celsius, 100 degrees Celsius, and intermediate temperatures. Then compare the measured temperature with the actual non-reference temperature. Percent error can be determined by using experimental value minus by reference temperature, which is the mercury temperature, divided by the reference temperature times by 100%.
Next, plot the calibration curves, measured versus actual temperature, and analyze the deviations. After that, determine the sensor accuracy by evaluating the percentage error and standard deviation for every sensor. First, set up the temperature sensors like thermocouple, RTD and thermistor according to the manufacturer guidelines and ensure the proper thermal contact. And then, connect each sensor to a digital multimeter or data logger.
The third step is immerse the sensors in the temperature medium. Example, a hot water bath or heating plate. Next, allow the sensors to stabilize for a few minutes to ensure accurate readings.
Record the raw outputs and convert them to temperature using the respective conversion equations. Then repeat the measurements at various temperature levels to compare the sensor responses.
Document all readings in a table for comparison and analysis. Last but not least, evaluate performance based on response time, consistency, and any observed drift.
In this experiment, we have three types of variables to ensure accurate and consistent results. First, we have the independent variable. This is the reference temperature. We change the temperature of the medium. For example, using the ice bath at 0 degrees Celsius, boiling water at 100 degrees Celsius, or an ambient water bath to test how the sensor performs. Next is the dependent variable, the sensor readings. We measure how each sensor, such as a thermocouple, RTD, or thermistor, respond to this temperature change. Third, we have the control variable. These are factors we keep constant to make sure our comparison is fair and accurate. They include the calibration method, sensor placement and immersion depth, stabilization time before recording, and using the same data acquisition system. By using these, we eliminate unnecessary variation and ensure valid comparison between different sensors. Next is expected results. Experiment all three sensors PT100, thermistor, and thermocouple are expected to respond differently under varying temperature. At 0 degrees Celsius, all sensors should gradually approach 0 degrees Celsius. The PT100 is expected to show the most stable and accurate readings, while the thermistor may respond faster initially. At 100 degrees Celsius, the PT100 should read close to 100 degrees Celsius with high accuracy. The thermistor may display a lower value due to reduced sensitivity at high temperature. The thermocouple should respond quickly but may show slight variation. At ambient temperature, all sensors are expected to stabilize near room temperature with minor difference. due to sensor calibration and carrier state. Before we begin any lab work, it's important to follow proper safety guidelines to protect ourselves and those around us. First, start by wearing proper attire like proper clothes to protect our skin. Second, always wear closed-toe shoes that protect our feet from sharp objects and hot surface in the lab. Third, don't forget your lab protection like safety goggles and gloves to shielding your eyes and hands from harmful substances. In conclusion, this experiment successfully demonstrated the sensitivity and behavior of PT100 thermistor and thermocouple sensor under different temperature conditions. PT100 was the most accurate and stable. Thermistor responded well at lower temperature but was less accurate at high. Thermocouple react quickly with slight fluctuation. Sensor choice depends on application needs and temperature range. That's all from us. Thank you.